So we've got the x plus 2 there and an x plus 2 on top. So I'm just going to go through and work these out. On the left, nothing is changing on the left. We've got x plus 2, x minus 2, plus x times x is x squared. X times 2 is 2x, all over x plus 1, x plus 2. When we add these things, they're going to have the same denominator. That was the whole point of doing this. Did I miss something?
Why is there x minus 2 right there?
Oh, I'm sorry. Yeah. Good call. It's still early. X plus 1. There we go. So x plus 1, x plus 2. In the top, we've got x minus 1 plus x squared plus 2x, which becomes what? X squared plus 3x minus 1. Yes, ma'am?
If you multiply like the bottom, like, would you get it wrong?
No, it still worked out too. Sometimes it's just easier to see it that way because here's what's going to cause you a problem if you multiply at the bottom. In a moment, I have to figure out where this is undefined. So when I figure out where it's undefined, if it's all multiplied out, that's not going to help me, right? Like whereas this, I can see in the denominators here that I've got an x plus 2, I've got an x plus 1, so I need to check those two things for where it's undefined. So I'm going to do that right here. X plus 1 is equal to 0. It can't be that. X plus 2 is equal to 0. Can't be that. So we get x is equal to negative 1, or x cannot be equal to negative 1, and x cannot be equal to negative 2, or else it would be undefined at those two things. So that's why that is more helpful factored. Yes, ma'am?
So it wouldn't be like wrong if you did multiply?
No, it wouldn't be wrong. It just might, nothing wrong with that at all. If you foiled out the bottom, here's what I would say is I wouldn't mark you off for not foiling out the bottom, and it might kind of hide where it's undefined. So it's why I might stray away from that. Like I would say, you could definitely do it. It would be extra work on your part. And if you made a mistake in the foiling, then yes, that would count against you. That's why I would say, why do it? All right, let's go on to B. So I think we can agree that these don't have a common denominator. So what can I do?
Multiply the left side, the bottom, and the top by x minus 3.
All right, well, let's first talk about how you got that. How did you decide on x, that what we're multiplying by? The difference of two squares. So we've got x plus 3 and x minus 3. Because this becomes that with the difference of two squares. Okay, so now that we know that, it's a little bit easier to see which one is missing something. Which one is missing something? The first fraction. And it's missing a what? It needs an x minus 3. So the bottom is going to be multiplied by x minus 3, and the top is going to be multiplied by x minus 3. So when we do that multiplication, we're going to get x times x is x squared, and x times negative 3 is negative 3x, all over x minus 3, x plus 3. X plus 3, x minus 3. We're just adding these things together. They're still going to have the same denominator because that was the whole point of getting a common denominator. X minus 3, x plus 3. And on top we've got x squared minus 3x minus 18. We just added those things together. Nothing could be combined. So we could check now, just in case, we can check to see, well, like, because sometimes people look at the top and they're like, well, how do I know if that top factors? Well, let's check it. Are there two numbers that multiply to give me negative 18 that will add to give me negative 3? Because a lot of times we get here and we're like, well, I don't know if this factors. Well, let's just decide real quick. Is this going to factor? Are there two numbers that multiply to give me negative 18 that will add to give me negative 3? let's see that, negative 6 and positive 3. That will factor. Well, that's kind of, oh, sorry, it's not caught up on the screen there. Yeah, I mean, if it factors, we need to check that. Everything else that we've dealt with has not factored yet, but this one did. Now notice, what did that do for me? Leaving only x minus 6 over x minus 3. When I check where it's undefined, I'm going to come back here and I go, okay, I've got an x minus 3, I've got an x plus 3, so I just need to check those. X minus 3 cannot equal 0, and x plus 3 cannot equal 0. So in this case, x cannot equal positive 3, and x cannot equal negative 3. So I'm just going to list that here. X cannot equal plus or minus 3. You don't have to write it as one answer. It's just a nice way to write them for you. Saves you time, saves you energy. So we always have to keep an eye on the top there to see, well, will that factor? None of the others would. This one did. All right, if anything can be factored, we need to factor it. Where can I start? Okay, what about it? Not difference of squares, but there is something to be done there. You're right, there's something to be done there, but not difference of squares. The square root?
Yeah.
So these, we don't know the square root of 2. We don't know the square root of negative 2, or we don't have the square root of both of them.
Can you cancel the 3x with the 3x?
No, because these are things being added or subtracted to each other. We can pull out a 2. And this becomes x minus 1. Right? That's the same thing. We're going to factor out a GCF there. And then over here, we've got 3x minus 2. Anything we can do in the denominator over here?
Take out a 3.
Take out a 3. And what's left over?
X minus 1.
So look, our denominator needs to have a 2, a 3, and an x minus 1. Do both of them have an x minus 1?
Yes.
Okay, so it's not the x minus 1 that I need to multiply by. But the one on the left needs to be multiplied by what on top and bottom? What is it missing? It's missing that 3 there. The one on the left does not have a 3 that it's being multiplied by. What is the one on the right missing?
2.
A 2. So that's what we're going to do to each of them. The left one is going to get multiplied by 3 over 3. And then the right one is going to be multiplied by 2 over 2. Okay. So 3 times 3x? 9x. 3 times 2 is 6 times x minus 1 plus 2 times each one of those things. Remember, it's times each of them becomes 6x minus 4 over 2 times 3 on the bottom is 6 x minus 1. Now look that they have the exact same denominator. That's what we wanted. Exact same denominator. So we get on top 9x plus 6x minus 4 all over 6 times x minus 1. What happens in the numerator there?
Can't you add the 9x plus 6x?
You sure can. What do I get?
15x minus 4.
15x minus 4 all over 6 times x minus 1. So I don't see anything that's going to cancel. That 15x minus 4 doesn't have a common factor. It's not the difference of two squares. Nothing I can factor out of there. So it looks like we're pretty much done here. I just need to find out where it's undefined. How do I do that?
Would you only do x minus 1 equals 0? Or would you do 6 over parentheses x minus 1?
So we don't need to do the 6, right? We don't need to do that one. Because 6 will never equal 0, right? That's never going to equal that. But the x minus 1, that could equal 0. So let's check that. X minus 1 is equal to 0, or cannot equal 0. So x cannot equal negative 1. Positive 1, sorry, positive 1.
Because I didn't pull up the 2 out of the 2x minus 2 or the 3x minus 3, but instead what I did is that I just multiplied, like how you multiplied 3 on one and then 2 on the other, and then I pulled out the 6 at the end because it made 6x minus 6.
I'm confused. So what did you multiply by if not the 2 and the 3?
No, like what I did is that instead of pulling out, I just multiplied, like how you did 3 over 3 times 3x. And instead of 2 times x minus 1, I did 2x minus 2. And then that made 9x over 6x minus 6. And then they both have the same denominator anyways. And then I pulled it out at the end.
This is what I'm not getting, and I'm sure you're saying it, I'm just not understanding. You said, like, so what is both sides being multiplied by? Like, what did you multiply by? How did you get to 6x?
On the left, I multiplied the numerator and denominator by 3. And on the right, I did it by 2.
What led you to do that? Why did you choose those numbers?
Because I noticed that since 2 and 3 share 6, the same thing went on the negative.
So you did the same thing. You're just not showing it. That's the problem.
I just pulled out at the end. I pulled out the 6. I didn't pull it out early on.
What you're doing is that in your head you're saying that this is a common factor of 2 on the left. This has a common factor of 3 on the right, which is the same thing we did. We just pulled it out front. So when you multiply by 6, you can do that, but as long as you're showing that work, it's a little more complicated that way, and like you may not see if something cancels, but it's no different than what we're doing.
No, yeah, I was able to get the same answer. I just did it different.
Okay. All right. Was that the last one, or did I skip one? Here we go. All right, talk to me. What's my first step? Okay, so this one over here is not going to factor. There's nothing that's going to factor there. But what about the one on the right? What does that become?
The top can be factored too.
Good. The top can be factored too. Talk to me about the top.
Take out 2.
Okay.
And x plus 3. And at the bottom, you x plus 3, x plus 3.
Okay.
So now the other side, another x plus 3.
Okay, great. So one of them has two of the x plus 3s. One of them only has one x plus 3. So that dude on the left needs another x plus 3. So we're just going to multiply it by x plus 3. So it's exactly the same. In which case the top on the left would be x times x is x squared. X times 3 is 3x. And then we've got x plus 3, x plus 3 on the bottom. On the right, we've got 2 times x plus 3 over x plus 3, x plus 3. Now, I know you might want to cancel now, but don't cancel yet. Like if we're canceling now, it's just going to cause us problems.
I have a question. So I didn't realize at the beginning that, because when I was working it out, I didn't realize that the 2x plus 6 at the top could have been like lowered or shortened. So I did it like how it is. Would I get a wrong answer?
Well, let's see what happens. If something in here ends up canceling out, then you might not have seen that. Like if that x plus 3 ends up canceling out, then you might not have seen that. And that's one of our things that we got to look out for. So, yeah, it actually looks like that's not going to help us, because here's what I'm going to say is like, see that x plus 3 on top and it's on bottom too? It makes me want to cancel it out. But if I cancel it out, then I can't add them together. So I go, maybe it wasn't good to factor out that 2. Maybe that didn't help me. So here's what I'm going to do is that I'm just going to show you what happens when we combine them together. We've got x plus 3 on the bottom. And on top, we've got x squared plus 3x plus 2 times x plus 3. Well, that right there still needs to be worked out. You can't cancel that out if things are being added or subtracted to each other. So let's just do this, put this back together here because that didn't help us at all. So we go x squared plus 3x. 2 times x is 2x, and 2 times 3 is 6. That's going to combine in the numerator. So sometimes we're going to try things that look perfectly obvious and it didn't help us out. And you go, that's okay, that didn't help us. This becomes x squared plus 5x plus 6 all over x plus 3, x plus 3. Now, I'm thinking something at this point. Like my brain is looking at something going, can I do something here? What am I looking at and thinking? That top might be able to be factored. Can it be factored?
Yes.
Into what?
X plus 3.
Now this looks like it's going to help me. So this is going to cancel with that, leaving only x plus 2 over x plus 3. Now, I'm looking for where this is undefined. So I'm going to go and say, look, x plus 3, x plus 3. It's just a whole bunch of x plus 3s. That's the only thing there. So we're just going to see x plus 3 cannot equal 0. X cannot equal negative 3. So we've got our answer here, and x cannot equal negative 3. I'll zoom out, sorry. Okay, 3 more and then what do we want to do?
Split the x's. Well, the numerator first.
Okay, the numerator on the left, on the right, which one are we talking about?
On the left.
On the left, what's going to happen to the numerator on the left?
You can take out 2.
Okay,
And then you're left with x squared minus 8. And then you can split the one with the different squares.
difference of squares on the bottom, minus. No, because 8 is not a square. Your good thought there was it looked like it might be something. If it had been a 16 there, we'd be good, but it's not. It's an 8. So we're kind of like, that didn't help me. Okay, so those denominators are not the same. On the second one, we're multiplying by which one? I'm sorry, what are we? Times x minus 2, because that's what the one on the right is missing. Okay, so on the left, doesn't look like anything's happening here on the left. Nothing terribly exciting over here. On the right, though, we can FOIL out that top. How do we FOIL it out? Okay, so x times x is x squared.
And then 2x, negative 2x.
Okay, x times negative 2 is negative 2x.
And then 4x.
4 times x is 4x.
And then negative 8.
4 times negative 2 is negative 8. All over x plus 2, x minus 2. We could what? Yeah, let's combine those some things in the top. So I'm rewriting here. I just like to keep it all. All right, now over on the top right, this is going to become x squared plus 2x minus 8. All over x plus 2, x minus 2. They have the same denominator now. So we've got 2 times x squared minus 8 minus all of the things that are inside of there, x squared plus 2x minus 8 over, yep.
Would it be better, because it's kind of complicated to switch it back?
Yeah, I agree. Yeah, that was going to be my next step. Is that what he's saying there is that what we did there is when we pulled out that 2, it didn't help us. It didn't cancel out with anything. It didn't make our life any easier. So he's saying what we did right here, let's go back to where we were, because actually it was probably easier the way we were. And I agree with him, because it doesn't look like I'm going to be able to add and subtract it like that. So let's just put this back together here. 2x squared minus 8 minus all the things that are in there plus 2x minus 8.
2 minus 16.
What's that?
2x squared minus 16.
Oh, yes, I'm sorry. I wrote 8. Thank you. Good call. Minus 16 over x plus 2, x minus 2. Yes, sir.
So when we're factoring the top, like the numerator, ever be helpful?
It will be sometimes. We just have to see what happens sometimes. Sometimes that'll make our life easier. Sometimes it won't. In this case, it didn't. It wasn't like the difference of 2 squares. It didn't make anything any easier for me. Sometimes it's just like something we like to look at. Really, it's the denominator that we need factored more than the numerator. The denominator is much more important to factor it. All right, the top there still has work to be done. Remember, this is so important here that this negative here goes to each one of those things. So that's what I'm going to do right now is I'm going to distribute that negative. 2x squared minus 16 minus x squared minus 2x plus 8. A negative times a negative gives me a positive 8 there. X plus 2, x minus 2. Anything in the top that can be combined?
2x squared negative x squared.
2x squared minus x squared gives me? X squared. So those are dealt with. Nothing for the negative 2x to do.
Negative 16 and 8.
Negative 16 plus 8 gives me?
Negative 8.
Negative 8. Anything else we want to check before we wrap this up?
Factoring the top.
Yeah, maybe the top factors. So we got to think to ourselves, are there two numbers that multiply to give me negative 8 that will add to give me negative 2? Okay, so we've got x minus 4 and x plus 2 over x plus 2, x minus 2. Anything canceling? Leaving us only x minus 4 over x minus 2. But I do need to find where it's undefined. And remember, we've got x plus 2, x minus 2. So we're going to check those. X plus 2 cannot equal 0, and x minus 2 cannot equal 0. Two places. So x is not allowed to equal plus or minus 2.
What if like you switch the plus and minus? Like in my answer right there.
In the box there?
Yeah.
You said x cannot equal negative or positive 2?
What if we like flip?
Like, just let me make sure I'm understand this right. Like if you wrote it like this?
Yeah.
Yeah, that's totally okay. Same thing. Because your answer still includes negative 2 and it still includes positive 2. It's just normally written with the positive on top, just so that like you'll see it always positive or negative, but your answer doesn't mean anything different. It's just not the common way to write it. Okay. Okay, let's go to F. All right, talk to me. They're not the same. One's a 2x, one's a 5x. They look similar, and it's kind of like makes you pause for a minute, but they're not the same. Therefore, what do we need to do? Yeah. We're going to need to do some multiplication. 3x minus 2. I'm just rewriting here so I have more room. 2x plus 5 minus 2 over 5x minus 2. So what things need to be multiplied by what?
2x plus 5 over, I think 2x plus 5 times 5 is good.
Okay, so the one on the left is missing a 5x minus 2. So let's add a 5x minus 2 over here. But then you have to multiply both the top and bottom by 5x minus 2. The one on the right is missing what?
2x plus 5.
Okay, so it's missing a 2x plus 5. Now they have the same denominators. So I already know my denominator is going to be 5x minus 2 and 2x plus 5. Let's talk about foiling the numerator on the left.
You get 15x squared.
First.
Minus 10x. And then minus 6x. And then plus 1. And you combine the 10 and negative 10x and negative 16x plus 6x. And you have negative 16x plus 4.
Okay, so that first thing is going to become 15x squared minus 16x plus 4. What about this one? What is that going to become? 4x plus 10. But remember, we are subtracting each of those. So it's minus 4x plus 10. So each one of those things will get subtracted. What I'm going to do here is I'm going to rewrite so that I've got this distributed here to each of those. 15x squared minus 16x plus 4 minus 4x minus 10. All over 5x minus 2, 2x plus 5. Where do I go from here?
16x negative 4x could be negative 20x.
Okay, so that 15x squared is not combining with anything, but the negative 16x and the minus 4x becomes a negative 20x.
And then negative 10 plus 4 is minus 6.
Now, the question is, does this factor? We're going to have to see. We're going to have to try this. So 15 times negative 6 gives me what? Because that top may factor. It may end up canceling out with one of these. Negative 90. So can we find two factors that multiply to give me negative 90 that will add to give me negative 20? And we just have to try them. We have to try factors. So you think of everything that you can think of to make negative 90. Like 2 and 45, 3 and 30, 4, 45, 20. That's not going to work. 5 and 18. 6, 7, 8, 9, and 10. Are any of these going to add up to negative 20? So 9 and 10, no. 18 and 5, no combination of those. 3 and 30, no. It doesn't look like any of these are going to be the factors we need. Therefore, this top here is prime. Unfortunately, we just had to check them. We go, it's not going to work out with those factors. None of those combinations are going to end up with a negative 20. Even if one's positive and one's negative, no matter what I do there playing around with them, it's not going to work. Therefore, this is actually going to be, yes, sir?
So on a quiz, it says when you write an answer, do we write prime next to it?
You could, but I mean, if you can show me that, let's say you were wrong. Let's say let's say you thought it was prime, but you were wrong. At least you can show me what you thought happened, and that's worth something. You know what I mean? I can follow along with that. I would write that there just because it allows somebody who's watching me to follow along with what's going on. All I need to know now is where is it undefined? How do I figure that out?
Use the 2x plus 5 and 5x minus 2.
Okay, so 2x plus 5 cannot equal 0, and 5x minus 2 cannot equal 0. So we get 2x can't equal negative 5. Divide by 2. X cannot equal negative 5 halves. That's one thing it can't equal. add 2, and we get 5x cannot equal 2 divided by 5. X cannot equal 2 fifths. Those are two things it can't equal. So all of that, and we get x cannot equal negative 5 halves. X cannot equal 2 fifths. Faith.
So the answer would just be like the 15x squared and then like.
Yeah, I was hoping something would cancel out and it would look like a little easier. I mean, it probably saved us on work. There wasn't any more work to be done, but unfortunately that's kind of frustrating when something's prime because you're trying to find something that it factors in hopes that it gets smaller, and it's kind of like rewarding when it does. You're like, oh yeah, this looks good. When it's prime, you're kind of like, ooh, I doubt it. I don't know if it is or it isn't. So sometimes it's tough when it ends up prime, but there are things out there that are prime.
Prime though on the test.
That's what he just said, is that, do you have to? And I said, here's why I would write it, is because what if you're wrong? What if you think it's prime and you're wrong? At least then if you're wrong, I can see what you thought and I can follow along with that and give you some credit for it.
Okay.
Whereas I may not know what happened. Like if you didn't write it there, what I might think is like, oh, they didn't even think to factor it.
But we wouldn't put it on like the actual answer.
No. You don't have to write down the actual answer. Just in your work there. All right. So remember, it's the denominators that we really care about factoring. That's the thing that we care about the most. We tried factoring the numerator a couple times, and that never helped us out. So let's just focus on the denominators. The instructions actually told us only to factor the denominators, but we noticed things and we started doing things, so I said, let's just try them. Okay, so what are we doing first? Difference of two squares. Notice that we're just kind of ignoring this numerator there. Even though maybe we could do something with it, we're kind of ignoring it now. But here we get x plus 8 and x minus 8, because that's the difference of two squares. Minus x minus 4 over x plus 8. Talk to me. Good. This one needs an x minus 8. So on the left, that's not going to change. That's got 2x squared plus 64, x plus 8, x minus 8, minus, and over here we have an x plus 8, x minus 8 on the bottom. But we have to FOIL this out now on the top. The numerator is x minus 4 times x minus 8. I don't want to distribute it to two things yet. Let's distribute it in just a minute. I feel like it's going to be harder if we distribute it now. We could, but let's just remember, like he's saying that, what about this negative? We're not ignoring it. It's there. We're going to use it in just a minute. So what is x minus 4 times x minus 8? How do I do that foiling there? And now I'm going to do exactly what he said there. He said, let's distribute that negative. It needs to be distributed to all those things there because we're subtracting all those things. So 2x squared plus 64 minus x squared plus 8x, I'm just going through and distributing, plus 4x minus 32. All I did was this. Like that. Let's talk about that numerator. What can I do with the numerator? Okay, 2x squared minus x squared gives me? That's those two dealt with.
64 minus 32.
All right, let's go in order, though. Let's try to keep them in order. Like, let's our x's first, so.
8x plus 4.
Which is?
12.
8x and 4x is 12x. 64 minus 32?
32.
Now, what might be possible on top? Do what?
So figure out if anything adds to 12 and plus 32.
it might be possible that this factors. So we're going to see, is there anything that multiplies to give me a positive 32 that will add to give me a positive 12? Positive 4 and positive 8? Okay, so x plus 4 and x plus 8. That's great. You can go back to the video and listen to that one anytime you want. Those x plus 8s are going to cancel out, leaving me only x plus 4 over x minus 8. Okay, the only thing I'm missing now is where is this undefined? And look, there's only two things in the denominator, an x plus 8 and an x minus 8. X plus 8 cannot equal 0, and x minus 8 cannot equal 0. So this is going to end up as x cannot equal negative 8, and x cannot equal positive 8. So here's my simplified version, and the two things that x cannot equal are plus or minus 8. You could write it as two answers. That's totally okay. I just like to combine it. Yes, ma'am?
What can you put the parentheses in the x plus 4 and the x minus?
That's okay. I just put it there because I like to throw them in there because sometimes when we multiply, if we don't put them around there, we get kind of confused as to, well, what am I supposed to multiply? I like to throw parentheses around things. Like, you could throw a parentheses around this up here. It wouldn't matter because it's one whole thing that we're looking at there.